And homework 3 is on geometric sequences. So the first section, same sort of idea as what we did with the arithmetic. You just want to determine yes or no, is the sequence geometric? So we'll look at number 1. So this one, you want to divide like the one on the right by the one on the left. So 16 divided by 2 is 8. 128, we'll type that in. 128 divided by 16 is also 8. So that means that yes, it is geometric. And then we can use that to give the next 3 terms. So we are going to continue multiplying these things by 8. So 128 times 8. So these numbers are going to get very large very quickly. So we've got 1,024. Multiply the next one by 8. That would be 8,192. And multiply that by 8. So we get 65,536. So here these, let's make like, bigger commas, I guess, separating each term so we don't mix that one up. I also forgot to write that the common ratio is 8. All right, so that's what you're doing for all of these, or a simple no if they don't divide out to be the same thing as you go term by term. For this next set, the rest of the page, you're writing a rule for each sequence. So you've got a formula, and that formula is a sub n equals a sub 1 times r raised to the exponent n minus 1. So you're going to be using that each time. So the a1 is easy. It's just staring right at you. The r you need to calculate each time. So this one, as you go term by term, negative 18 divided by 9 is negative 2. 36 divided by negative 18 is negative 2, etc. So we figure out, all right, r is negative 2. So that's the common ratio. You could keep multiplying it out. A1, of course, is easy because it's just this value right here. So let's write a sub n is equal to a sub 1, which in this example is 9, times, and then we have the common ratio. Usually a good idea to put it in parentheses, especially in a situation like this where it is negative. And then we have n minus 1. So the rule itself just looks like that. And then we want to use that rule to figure out whatever term they're looking for. So if you're looking for a sub 8, that just means that the 8 is going to get subbed into this formula in place of the n. And that is something that can just get subbed right into your calculator. So this would be negative 2 raised to the 7th power. So you could even figure that out. Like you would have negative 2, 4, negative 8, 16, negative 32, 64, negative 128. So it's an odd power, so you know that it's going to end up being a negative number. So we have 9 times negative 128, and then multiply that by 9. So we end up with negative 1,152. Okay, so that's the first one. That would be the 8th term if you were to keep going and taking each one of those values and multiplying them by negative 2. All right, let's see. Next page, we'll do number 13. So we want to write a rule again. So this one, you're given the r. So these ones are actually a little bit more straightforward, and some of them you're given another sequence later on, so you can divide that out a couple times, figure out what r would be. So writing a rule, so same formula that we had before, so you've got a sub n equals a sub 1 times the common ratio raised to the n minus 1 power. So we set that up for number 13, and then you want to find a sub 7. So a sub 7, you would sub that in, so 7 minus, jumped ahead. 7 minus 1 would be 6. So we need to know what 6 to the 6th power would be, and that would be a very large value. So we have 4 times, so 6 to the 6th ends up being 46,656. And we can multiply that out. So we end up with 186,624. All right, so common ratio of 6, and things would get pretty big pretty quickly. Another thing that you can do just to kind of test out that you're right, especially if you have a calculator, so it starts with 4, and then you're just multiplying by 6 each time. So this would be term 2, 3, 4, 5, 6, 7. So you could just double check that your formulas are actually working out correctly. All right, and then we've got some application problems here. So Jameson opened a new savings account, $1,500. That's like your A1. The balance of the account is given in the table below. So each month, that's like your N. So 2 years would be N equals 24, because that's the number of months. So we want to figure out a common ratio. So we can take these values and we can divide. So 1545 divided by 1500, and then 1591.35 divided by 1545. So you've got this common ratio of 1.03. Okay, so this R is 1.03 when you divide term by term. So this is actually like an interest problem, really. So this is showing that you've got 3% interest. So this formula should look familiar to you from a couple units ago when we set it up. So A sub n equals the initial amount. So this is your A1, so 1,500. And then we have the R, so 1.03 raised to the n minus 1. So if you remember, this is actually extremely similar to like the compounding stuff, the exponential growth and decay stuff. So this we wanted to know in 24 months, which is 2 years. So the amount after 24 months, we could just sub right into this formula. So 24 minus 1, that you could just sub straight into the calculator. So we do 1,500 times 1.03, and then raised to the 24 minus 1, so 23rd. Okay, so that gives us this. Remember, it's money, so like the 0.397, etc., you'd round that to 38. So it'd be $2,960.38.